So now in the last couple of classes, we've focused on the TaskGang framework. So I'm not going to spend any time covering the TaskGang framework here. You can go back and watch the previous videos to see what TaskGang is all about. Instead, we're going to jump ahead and take a look at something called SearchTaskGangCommon, and we're going to talk about what capabilities it adds above and beyond what we get from TaskGang, which is the root of all the different tests that we're doing here. So the SearchTaskGangCommon class is a subclass of TaskGang, as you can see from this UML diagram, but it also plays the role of an abstract superclass for all the other subclasses of it. So essentially, it's beginning to customize the TaskGang framework so that the framework can be used to concurrently search for keywords in lists of string objects. And you can find the code here at this link in my GitHub repository. So what does this class really do? What this class does is it factors out code that's common to all the subclasses that are created by SearchTaskGangTest. That was a driver program we looked at. And you can see there's a fair number of methods that are customized from the TaskGang superclass here. And that's going to provide a nice foundation for all the other things we're about to do. So one thing that's done in the constructor is it creates an iterator that's used to access the input. And as we'll see, there can actually be a number of different lists in the input. So we can have cycles. You can have multiple cycles. You can process things one cycle at a time, kind of like an assembly line where cars come along and you work on a car, a group of people, group of threads, parties, whatever, work on the car and do their thing. And then it goes on to the next phase in the assembly line. One of the things we're going to do is we're going to take an array that's passed in as a parameter here, and we're going to turn it into a list. And the way we're going to do this is by using the arrays as list factor method and converting the next array element into a list and returning that as the next input to be processed. Now, this particular example, the first one we're going to look at is just going to use a single set of input strings. That's the one shot, but the other ones are going to use multiple sets of input strings. The next thing we're going to do is we're going to create a virtual thread executor that will start a new virtual thread for each string that's going to be searched. And to do this, it's actually very cool. We make ourselves an executor by calling the setExecutor method here, which is a setter method that's defined in the TaskGang framework itself. And we pass in a method reference to start virtual thread. And start virtual thread is this cool modern Java capability that will create a new virtual thread every time the executor's execute method is called. So we're kind of associating this here and making it so it'll be connected together with the executor that's expected by the framework. So as you can see here, we have the initiate TaskGang hook method. And what it's going to do, it's going to get called back from deep in the bowels of the TaskGang framework when the TaskGang's main run event loop is triggered. And it's going to iterate through all the elements in the input string during this cycle. And for each input element, it's going to call the execute method on the executor, which is going to go ahead and create a new virtual thread. And what it will execute is the results of calling the make task factor method, which will create a new runnable for that element in the input list. So there's one runnable per input string, and each runnable is then run by a virtual thread. So there's a thread per input string concurrency model here. Each task runs the same logic, and this is provided by the process input method. And this is actually something we've seen in some other examples like this. It just iterates through all the words to find, and for each word to find, we call the search for word method, and that goes ahead and looks in the input data to see if it finds a match, and it returns results, and if it gets any results, it prints them out. And it does that with a synchronized statement because we don't want to have different threads scrambling the output. Notice that the tasks that are run here are embarrassingly parallel since there are really no dependencies between any of the items. They all just run concurrently in different virtual threads. Here's what search for word does. It goes ahead and searches for all instances of word in input data. And it's going to use a really cool factor method called make results regex, which we'll take a look at here shortly. It returns search results. Search results are a class that tells what input data we're dealing with, what word we searched for, and how many hits we found, as well as the indices into the input data where the hits occurred, where the words were found, if they were found at all. And we're going to use a regular expression to check how many times a word appears in the input data. And we'll take a look at that here in just a minute. We also have another barrier synchronizer mechanism called await tasks done. And this is a hook method that's called to block the calling task, the main task, until all the other background tasks have finished doing their thing. And the way it does that is it just simply calls the await method on the exit barrier. And we use rethrow runnable to convert the nasty Java checked exceptions into runtime exceptions, which makes the code cleaner because you get rid of those crazy try-catch blocks everywhere. There are no other commitments to hook methods defined by the TaskGang framework. These are going to be deferred to subclasses. So there's no specific barrier synchronizers. There's no specific source of input strings. That's all going to be provided by the subclasses. And you can see here, this is how that's done by essentially having them extend SearchTaskGangCommon. We'll take a look at those shortly. So let's go ahead and take a look at the code for SearchTaskGangCommon. So now we're back in the Barrier Task Gang program, and we're going to take a look at SearchTaskGangCommon. Here is SearchTaskGangCommon. You can see it's an abstract class that extends TaskGang and parameterizes it with a string. We have a words to find field that's an array of words to find. We have an iterator to an array of string objects that are going to be used to provide the input to be searched. We have the countdown latch, which is going to be used to control when the program can shut down after a test has been run. The constructor initializes the fields and sets the executor to be the virtual thread executor. So it'll go ahead and create a virtual thread every time the execute method gets called. Here's the get next input method. This will check to see if we're all done, if all the inputs have been processed. If so, we're done. Otherwise, we increment the new cycle and we go ahead and convert the array of string objects into a list using the arrays as list factor method. Here's the initiate TaskGang method. It calls the initiate hook, which probably doesn't really do anything that we care about here. But what the main point of the initiate TaskGang is to iterate through all the elements in the input list and make a runnable for each one of those. Just to remind you what make task does. Here's the make task method. You can see it's going to go ahead and find that element in the input, call process input on that element. And if all goes well, it'll call task done. And if something goes wrong, then we're going to have an index out of bounds exception that can be used to clean some things up, as we'll take a look at later. So that's what gets returned for make task. We then go ahead and execute that. That will run in a virtual thread. Here's process input. We talked about this before. Nothing too profound. We just search for each word in the input. And if we get matches, we print them out using a synchronized block to avoid having race conditions or problems with the output being scattered. And here's the await task done method. You can see that that goes ahead and waits for all the tasks to finish. You'll see how those get cleaned up later. And then here's search for word. This is similar to what we looked at before, but a slight twist that I want to focus on. So we take a word in the input data. We call new search results constructor, tell it the thread we're running in, the current cycle, the word, and the input data. And then we take the word and the input data and we go ahead and come up with a list of result objects, if any, I should say if any, because they may not be no matches. And to do that, we call make results regex. And this is a cool little example that uses regular expressions as follows. We make ourselves an array list to store the result objects. We compile the word into a pattern. We associate that pattern with the input data. And then while there are any matches that are left, we try to find a match using the regular expression matcher. And what that'll do is if we get a match, start will tell you where the match began. And we create a new result object, add it to the results list, update the index to start searching from the next portion here. And then we loop back around again and try to do another find. So if all goes well and there are matches, we'll return a list of results. If there are no matches, we'll return a list that doesn't have anything in it. So that's how we can use regular expressions in order to do this type of searching. So that's the end of SearchTaskGangCommon.